Okay guys, here's my first video. This video is going to be over IMC and RMC. IMC is Article 342, which is intermediate metal conduit. Okay, so if you watch this video, it's going to help also if you look and follow along in your code book. Okay, so I got to start with a joke today, because my students said that they missed my wonderful jokes. So, here goes. Frenchman walks into a bar with a parrot on his shoulder. The parrot was wearing a baseball cap. The bartender says, "Well, that's really neat. Where'd you get that?" The parrot says, "France. They got millions of them there." Okay, that's your joke for today. All right, go ahead and turn to Article 342, Intermediate Metal Conduit, type IMC. Okay, so the Article 342 dot 1 is or dot 2, excuse me, is a definition. Definition of intermediate metal conduit is a steel threadable raceway of circular cross section designed for the physical protection of conductors and cables and for the use as equipment grounding conductor when installed with its integral or associated couplings and appropriate fitting. It is a lot thicker, I guess, than EMT, which we talked a lot about EMT, and we talked a little bit about rigid as well. But we're gonna go through that also. It's a lot more rigid than EMT, but it's not quite as rigid as RMC. And again, it's made to protect the conductors. It's going to be able to withstand a lot more damage from stuff hitting it, and so it can be used in a lot more places than EMT as well. So, okay, go on to Article 342.10, uses permitted. And overall, we're going to go through this fairly quickly. Like I said, you're supposed to read it. Your assignment was to read it first. And so I'm going to go through this fairly quickly, and we're not going to read like we did in class. So, but we're going to go through some of the main points here. So, use is permitted. 342.10a says all atmospheric conditions and occupancies. Use of IMC shall be permitted under all atmospheric conditions and occupancies. Okay, basically anywhere you want. We have corrosion environments. That you can have it in it says B there says you can have it in environments with corrosive influences when it's protected by a corrosion resistant material. Okay, so and it's a lot like EMT for the fact that EMT you can use in a lot of different places too, as long as it's protected by the right corrosion resistant material or the weatherproof material. Same deal there. And again, cinder fill. Same thing, and then wet locations, you gotta protect against corrosion. And again, a lot of times that is either with a non-metallic coating on it, or they'll paint on a coating that just protects it from that corrosion. One thing I want to look at though is E. If you look at E, and then this 2017 or 2020 code book, E is new, and it says severe physical damage. IMC shall be permitted to be installed where subject to severe physical damage. Okay, severe physical damage is a lot, right? That means it can take a lot, and so, but that also goes to show how thick it is. It's thick and it's thick hard metal, so it's gonna be able to withstand a lot. And so we can put it in about any atmosphere, anything that's going on, we can use it. So it's very, very nice. But it's starting to get heavier. We like the MT because it's a thin wall conduit, right? And so it's easy to bend, easy to use. Now when you get to your IMC, RMC, they're a lot thicker. They're gonna be a lot harder to bend. And so once we, you can do 3/4, maybe even an inch of EMT, pretty easy, fairly easy by hand. You're not gonna do that with RMC and IMC. You're gonna have to use an electric or hydraulic bender. Okay. All right. Of course, 314 or 342.14 talks about dissimilar metals, and just like anything else. We don't want to have any dissimilar metals in contact with each other unless they're coated with something that's going to stop those metals from actual contact. Again, because we know that if two dissimilar metals contact and you have water and air, they're going to start to corrode. Okay. Okay, so I'm going to put on here. Sorry for the surroundings. Eventually I'm going to get some stuff set up for like an actual office or a classroom thing here in my house. This is kind of a put together deal here, just to get the video out for you. But as the videos come, I'll get more and more set up. Okay, so, alright, so intermediate metal conduit. Now, 342.20, talking about size, when we talked about minimums and maximums with a lot of different stuff. Okay, so for IMC, according to 342.20, your minimum size is 1/2 inch. Okay, and that's just like EMT or most of the other things. Most of the other things, besides if we're using it to connect motor leads on the motor itself, we're going to use 1/2 inch as smallest. 3/8 of course would then be used can be used, I guess, for the motor leads. Okay, so then B on 342.20 says maximum size is 4 inches. Okay, so it's just like EMT. So even though it's more rigid, it's still not rigid enough where they're going to increase our size yet. Now when we get to RMC, we're going to see that they will. But EMT is, IMC is still not quite rigid enough where they're allowing an increased size in diameter. All right, 342.22 number of conductors. That's our conductor fill chapter 9 tables, which we went over. And I can always do, if people need some more help with that, I can do a video on how to calculate conductor fill for conduit at another time. Okay, 342.24 and 342.26, bends how made and bends numbered in one run. Okay, so your bends obviously are going to be made with most likely either a electric or a hydraulic bender. Maybe 1 to or 1/2 inch to maybe 3/4. You might be able to do by hand, but you're going to get quite the workout doing it. And then the number of bends in a run, just like everything else, maximum is 360 degrees between pull points. Okay, and if you hear some talking in the background, sorry, my wife's aunt's here. So, anyways, like I said, eventually I'll get this set up hopefully in the basement, and then it'll be a little bit better. So, I just want to get one out for you guys so we can start these videos so I don't have to edit so fast. Okay, so 360 degrees, just like normal between pull points, junction box, or any sort of conduit body. And we've talked about this before. That 360 degrees is for pulling wire. So when possible, keep it less than 360, because if you go all the way to the max 360 degrees, you're still going to have a hard time pulling through. It doesn't matter if it's a few wires or a lot of wires. Okay, securing and supporting. IMC is a lot like EMT and RMC, where straight runs. Okay, it's a little bit harder to write down here, but like I said, we'll get all that fixed up later. Okay, so 3 feet and 10 feet. Now, the one thing also kind of like EMT. Sorry, the one thing kind of like EMT is you can that 3 foot can go out to 5 foot if there is no place to support it within 3 feet. Okay. Let's see. Then we also, if you look at under supports, which is 342.30B, number 3, it tells you that we can go, if we're going vertical from a piece of equipment like into a ceiling, then you can, that distance, as long as it's securely supported at the piece of equipment or machine and at the ceiling, we can go 20 feet, just basically like a drop. Now, you'll kind of see some of that. A lot of times you're not going to use IMC or RMC for that, but if it's in an environment where you need that strength, you will. If you look at next time you're in school, whenever that ends up being, if you look in our the machine tool area, going down to their machines, you'll see that we have some of those drops down, but we use actually flex for it for the most part. But the biggest thing is make sure it's securely supported at the top so it's not pulling down on that conduit, and then it's securely supported at the bottom so that it's holding it up, so it's not pushing into that machine. Okay, so we'll go up to 20 feet there. So we're going to go ahead and look at 342.42B. It says running threads. Running threads are not allowed. The actual article says running threads shall not be used on conduit for connection at couplings. Now, what are running threads? Okay. One second. Okay, apparently my kids were using this to draw. I can get you to see this a little better here. Okay, so what running threads are is basically you take a conduit, piece of conduit, and at the end, here, this would be a manual thread thing. You thread it longer than you actually need. Okay, and that can be on this end and the other end, or a lot of times you only need to do one end. Now the reason that they do that is so that the next piece of conduit here it's got regular threads. If you have, and I'm not an artist, remember that, so those are the same size. If you have a tight location where you can't move these apart and to spin them and stuff, to lock your coupler on, what you can do is you can take your coupler, if you do those running threads, spin it way back like this, put your pipe up to that, and then you thread it back using a wrench or something and thread it on here this way. Okay, why do they not want us to use this? Why can't we use this, I guess, because it says shall not. And it's because when you thread farther back, one of the reasons that we thread this only so far is because that way once we get to the bottom end of it, it's tight. Okay, and so we thread it onto the one, and we bring the next one, and we thread the pipe into it, right? And so then both ends are tight, so it's not going to come loose. Well, if we do our running thread with these being extra long, even if we thread this on here tight, we're not going to be tight on this end. So either this pipe can come loose, or it makes it easier for that coupler to come loose. Okay, so that's why we can't use running threads. But that's what when I say running threads, that's what they are. It's just you thread it way longer than you need to, so you can screw that coupler on, bump it together, and use the coupler to screw it and tighten it back down. Okay, don't use that. Okay, so then if you look at 342.6, it's bushings. It says, where a conduit enters a box, fitting, or other enclosure, a bushing shall be provided to protect the wires from abrasion unless the box, fitting, or enclosure is designed to provide such protection. Okay, so what that is saying, if we have a box here, make sure you can see this, okay, so if we have a box here, and our conduit comes up into this box and it's got its threads here, right? And we thread on a lock nut or something on both sides, or we come into that, or if we have a threaded hub, let's say down here, that we're going to thread into, right? If this is open threads, we have to put a bushing over top of it. And what that is, it's very simple. It's basically a threaded cap. And this threaded cap, you thread it on there, so when you pull those wires through this way and this way to go wherever they need to go, they're not going to rub up against that sharp piece of metal at the end of the threads. Okay. Now it says unless the box itself protects from it, every once in a while, or sometimes, you'll get a box that on the bottom side has a threaded hub here in the box, and then there's a hole right here so that you, when you put your conduit in, you'll actually thread your conduit in here, and then these two ends here protect the corners. If you can see that right here. And so if it has that built into it, then we of course don't have to worry about it. But if it doesn't, we have to put this plastic bushing on it to protect those conductors, right? And again, it's because of cutting and stuff. Okay, almost done here. We are on splices 342.56 splice and taps. Splice and taps shall be made in accordance with 300.15. Okay, 300.15 says that it cannot be basically inside the raceway, right? It has to be inside a conduit body or a junction box or something like that. Okay, so it'll be a junction box, all those different things. It can't be inside the conduit itself because splice and taps need to be what? Accessible. Okay, and so make sure you don't wire nut it, pull wire through because you ran out of wire or something and have that splice inside there. The splices have to be in a box. Okay, and of course 340.42 is grounding. IMC shall be permitted to be an equipment grounding conductor. Okay, so we can use that as equipment grounding conductor itself. We don't have to pull a ground in. Again, what I always say is pull it in anyways, right? Now, IMC is a little bit different than EMT because of the fact that the RMC is normally threaded. So I'm more comfortable using the conduit as a ground if everything is threaded. But I still would suggest pulling a ground in. Just know that IMC can be used as your grounding your grounding conductor. Excuse me. And 342.100 construction. It says it shall be made out of steel with protective coatings or stainless steel. Okay. Now, most of the time, I believe that it is that your steel with a protective coating is cheaper than your stainless steel, and so a lot of times that's what they'll do. They'll actually have protective coating on your steel, or you can use stainless steel obviously without protective coating because it's not going to corrode like regular steel is. Okay. All right. The last one I want to talk about today is, or for this one, is marking. Okay. Each length shall be clearly and durably marked at least every 5 feet with the letters IMC. Each length shall be marked or required. Shall be marked as required in the first sentence of 110.21a. Okay, so that's basically saying that that needs to be marked with IMC and the size and all the others, the number for it. But the thing is us as electricians, we don't have to worry about that because we don't manufacture it. That's more for the manufacturers. Okay, so all right, so this was on IMC Article 342. I'm going to turn this back around, see if I can bring it a little closer so that you can pause it if you need to copy. Okay. If there's any questions or comments about this, go ahead and put it below in the video, or my students, of course, you can message me on Line app or text message or whatever. Hopefully this kind of covered most of it and it makes some sense. So, all right. Next video will be RMC.